Hello everyone and welcome to the Batlow Online Future Orchard Walk. For those of you that don't know me, my name is Rose Daniel and I'm the Technical Manager with APAL. We're sorry we can't be there with you in person today, but we're really happy that we can still present to you the Future Orchard program and share information with you. The theme for today is The Future is Now, and you'll be hearing from Dr. Nigel Schwartz from TIA, who will provide a summary of the learnings from the PIPS2 fertigation research project and launch the Sonata tool. Jonathan Brooks from Ag First will explore current and future issues such as labour, trees, quality, climate and technology. And Kevin Dodds from New South Wales DPI and your frontline advisor will provide an update from the latest demonstration trials that he's been running in Batlow. And then to top it all off, Jonathan will take us on a walk of several New Zealand orchards. So before we move on to our guest presenters, I quickly wanted to run through some of the activities that have been happening within APAL over the last few months. So as you in Batlow are probably more aware of than other people around the country, a lot of Eastern Australia was affected by bushfires last summer, and APAL was involved in assessing the damage and preparing a submission to the government to support recovery for that. Applications are currently open for the New South Wales government funding. And if you haven't heard about this, please get in touch with Kevin Dodds or with us at APAL and we'll help you along with that. The first round of applications are actually due today. In May, staff within APAL were trained in the emergency plant pest response deed. And we have been developing standard operating procedures for our biosecurity responses internally so that we're better prepared in the event of an exotic plant pest entering Australia and affecting apples or pears. So these types of emergencies have made us more aware of the value of understanding what constitutes the apple and pear industry. And we've also commenced a tree census pilot study so that we know how many trees and what size orchards we have in the event of an emergency, and we're able to better respond in the future. There's also been a lot happening in the future business space. The future business team are continuing to collect insurance related data to understand how much businesses are paying for insurance and what type of coverage is being accessed. And if you'd like more information about that, please get in touch with Rochelle Zealy, the manager of Future Business. You can see her email address there. Otherwise, if you call up the APAL office, we'll be able to put you in touch with her. And finally, we're planning the next round of Future Orchards, and we'd love to hear any feedback from you so that we can continue to make sure that we're providing relevant content. Okay, so without further ado, I would like to introduce Dr. Nigel Schwartz, who will present the outcomes from his research into improved water and nutrient use efficiency for apple orcharding. Nigel is a research fellow at the Tasmanian Institute of Agriculture at the University of Tasmania. I'm sure many of you may have met him before. His research expertise is in the field of tree physiology and tree crop nutrition. And Nigel leads the fertigation project for the Hort Innovation and Apple and Pear Levy funded PIPS2 program. Nigel, it is now my pleasure to hand over to you.
Hi, good morning, everyone, and thanks so much for joining us this morning. It's a great privilege and pleasure that I get to present this bit of work to you. This bit of work is sort of the culmination of 4 years of research on apple tree nutrition and water use, and essentially that's sort of come together into what we're calling Sonata, and that's our online Excel tool that hopefully. Well, we'd really like to see as many advisors and growers as possible pick that up and use it to really try and understand and strategically manage their water and nutrient resources. So this bit of work is not by no means my work. It's also a collaboration between Plant and Food Research New Zealand, where Steve Green is from. Steve Green is the brains trust behind the Sonata tool, and he's a data scientist and has compiled all the data that we've collected over the last 3 or 4 years. Marcus Hardy is a soil scientist at TIA. He did a lot of the soil characterisation work and led a lot of the analysis there as well. B. Zheng Tan was a PhD student, and he has helped us so much with all the plant nutrient and nitrogen moving through the tree work, and I'll show you some of that data a bit later on this morning. And then Dougal Close. So this work is part of the PIPS program. PIP stands for Productivity, Irrigation, Pests and Soils. And we're into this is the second iteration of PIPS, and this is the second part of the fertigation work that is part of PIPS. And yeah, so it's a 4-year research project, and we're sort of just coming to the end of it now. And one of the outputs of this project is Sonata. So I'm just going to move along. So Sonata is the primary model which is coming from this project, and it stands for Strategic Irrigation and Nitrogen Assessment Tool for Apples. Essentially, it's a decision support tool, or a strategic decision support tool that will hopefully guide advisors and growers on the optimization of irrigation and nitrogen application from each of the major apple growing regions in the country. The focus of Sonata is really trying to understand how water and nutrient and nitrogen application, in particular types, rates, timings, can be managed to satisfy the tree's requirements, and also mitigate leaching, optimizing productivity without a cost to fruit quality. And this is what we're really trying to focus on: how we can manage our irrigation and nutrient resources to improve productivity without impacting fruit quality. Or if anything, improving fruit quality. And this tool requires climate and soil data, which is based on local databases and soil characterisation from regions across Australia. And it also requires inputs from the growers and advisors on the tree varieties they use, the kind of yields that they're expecting, and various aspects of the way that you manage your trees in your orchards. But just so that we can, I guess, get a bit of a handle on what has gone into the tool and what sort of drives the background of the tool, it's really important for us just to grasp just some of the physiology of the apple tree. And when you guys will know this well, we're sort of in this autumn period at the moment. Nitrogen has been withdrawn from the leaves as those leaves are falling off and allocated to storage. And those storage organs are, in your branches, in your trunk, in your roots, and that will happily sit there over the winter period. And then come early spring, that nitrogen resource will be remobilized and will provide energy, or provide the nutrient required for the first sort of 2 months of growth, up until about 1 month after full bloom. And that's a really important aspect of our nitrogen budget that often we don't consider, because we know that the remobilization portion of the nitrogen pool that drives our apple tree actually probably makes up 40 to 50% of the total N that is actually required for tree nutrition. And the balance can come from mineralization sources, or from root uptake, and also the nitrogen that we put on as fertilizer. So if we move up to the top right chart here, this is kind of the story around nitrogen use efficiency. So this is the amount of nitrogen that gets allocated to the crop, plus the nitrogen that gets used to grow the tree, relative to the amount that gets put on. And obviously, we know that the remobilization is a resource. We know that root uptake from mineralization of organic sources is a resource. And we also know that the nitrogen that you put on is another resource as well. But ultimately, what you manage, we want to make sure that we're doing that as efficiently as possible. Then the other aspect of the Sonata story is water uptake. We know that there's a really strong interaction between nitrogen and water, and that's why we have to consider both in our thinking. And so the way that we have adopted or learnt about tree water use is through sap flow measurements. And that's about the most powerful research tool that you can use to really track the movement of water from the soil up into the tree. And we've had sap flow measurements in trees, in adult trees, where in adult gala trees that are yielding 70 to 80 tonne a hectare. And we've also had sap flow in really young trees, going from just as soon as they're planted right through until they're yielding in their 3rd and 4th leaf. So that has given us a really clear understanding of how much water an apple tree uses in an orchard over a number of tree age classes. So there's 2 other really big aspects that have to be, I guess, characterized and parameterized to make sure that this tool actually makes sense. And the first is soil characterization, and making sure that we know exactly what your soil is doing and what type of soil that you're growing your apples on, and also the climate that you're growing your apples in. So firstly, the characterization of Southeast Australian apple growing regions, soils there. We obviously, there was a couple of guys came up from TIA and worked with a number of growers in the Batlow area to look at, and they dug big trenches in your orchards, and we're really grateful for that opportunity that you guys let us get in there and dig big holes. And we looked at the morphology of the soil. We looked at the chemistry of the soil. So this is the whole nutrient composition, your organic carbon in a number of forms, your plant available nutrients. Then most importantly is the hydrology. So this is how much water your soil can hold, how much water is required for irrigation, how water moves through the soil. So if there are any cracks or any particular aspects of that soil type that you're growing your apples in, we've learnt. And then of course we've made some recommendations on how to best manage that soil to get the most out of it. So all that information can be found on the Apple Soils website, and there's a link to that on the APAL website. And you growers can go into your region and click on the soils that most likely represent what you grow your apples in, and you'll actually be able to select that soil type in the Sonata tool. And what's really important is if you're unsure where what soil you might be growing on, you've got a bit of an idea. You've dug a trench before, or you've done a bit of digging in there, and you've got a bit of a picture. You can go into the pictures of the soil and you can see exactly what find something that looks the same, and click on that, and you'll get all those properties there, and probably some stories about how best you can manage that soil. So moving on to this is what the background of the Sonata tool looks like. So you won't actually be able to see this sheet, but this is where all the soil information is held, and we've got a wide range of soils there, and there's a whole stack of information that we've learnt about that, like the sand content, the saturation point, the clay content, organic carbon, organic N, and all that information feeds into the outputs of what we end up receiving from Sonata. So we only got to 4 major growing regions across the country. We're still missing out on the Stanthorpe area, and we still miss out on the WA area, but we have we are actually going to go sample the WA area very soon. And there's a whole stack of other soils from the Victorian soils database that we've incorporated in there as well. So, I mean, you won't see this page, but you'll just have a very simple drop-down menu for you to be able to select which soil type most represents the orchard that you're managing. And then the next major page that, again, you won't be able to see this, but this is all the background inputs that go into the tool. The software is preloaded with historical data from 22 climate stations. These have been downloaded from the Australian Bureau of Meteorology database, and these records include daily values of ETO, air temperature, rainfall from the harvest seasons of the last 18 to 20 years. And then, I mean, you guys will select the climate based on where you're growing your apples in. And then the next, really important part of what goes into parameterize the model is really trying to grasp the story around how much water your trees use, and that's critical. So I've got a couple of charts here where we've actually recorded sap flow over a season for a 2-year-old tree, and then we've recorded sap flow over a season for a 3-year-old tree. And you can really see that size, the canopy size is really driving tree water use. So if we look at the peak of summer in January, tree water use, look at the black chart, the black line is sort of up between 5 and 6 litres per day. This is what your young trees are using. They're obviously, they might have a very small crop on them, but they're about 5 to 6 litres a day. And you can see the ETC is really cranking up there as well. And you can see that there's a fair bit of variation there, and that variation is really influenced by the climate. So we have a cool day, we have a cloudy day, we have a windy day, or a really hot day. That'll very significantly drive tree water use. And we've got the relationships on that really down pat. And we feel like we know that we do, because we can actually model sap flow now to very closely represent actually what the tree's doing. And I think there's just that little chart below is also really worthwhile showing you, because all of a sudden, as soon as we get to a 3-year-old apple tree, so it's in its 3rd leaf, it's got a bit of a crop on it. You know, we've had a few hot days there in February. You can see the black line is the sap flow, and then the red line is the modeled value. And you can see you're pushing 8 to 10 litres a day. Now, we know that with an 8 to 10-year-old tree with a full canopy, 3 to 4 metres tall, a single axis with 70 to 80 tonne a hectare of crop on it, we're up to about 30 litres a day on a really hot day in the peak of summer. So there is a fair bit going on with tree water use, and it really pays to have a good understanding of what's going on there. So if on that bottom left chart there, we can really see exactly as the tree gets older, the model inputs, and there's a curve there that shows exactly that we can now predict tree water use for a 2-year-old to 14-year-old tree. And you can see it kind of flatlines a bit as the tree gets to about 8 to 10 years old. And then this is really shows the value of the data that you guys put in to the OrchardNet site. So we've used OrchardNet database to harvest data for apple yields across the growing region. So we have data, really solid data on 4 varieties across the country, where we have essentially just grabbed exactly how old the tree was and what the tree yielded for that age, for that season, and we've modelled that onto a chart. And say you can see Granny Smith's at the top there, where we've got between 75 to 100 tonne a hectare for a 10-year-old tree, where that line starts plateauing and continues on to about 20 years. And that data is really critical for us to be able to gauge exactly what kind of yields we can expect from this variety of apple at its age that you end up inputting into the tool. And then Pink Lady is a bit different, and this actually shows the value of kind of more modern varieties as well. 5 to 10 years, where you're starting to yield as already 75 to 100 tonne a hectare, and this data is also inputted into the tool. Now, obviously the tool is limited by the amount of data and the quality of the data that we've got. We've only got data on good data on 4 varieties so far. We'd love to get more and more data from different varieties, including the more, the club varieties as well, that a lot of growers are starting to grow. And then we need to really try and understand what a tree does with nitrogen over a season. And that's really important for us to get our nitrogen recommendations, or the understanding of how much nitrogen a tree is going to use from one season to the next. So the way we did this, and this was done by my PhD student B, he set up some fertigation trials using a nitrogen tracer, and that nitrogen tracer is 15N, so it's a stable isotope of nitrogen. It allows us to track the difference between the standard isotope, which is 14N, and the fertilizer nitrogen, which has been labeled with 15N. So on that chart on the left, so B set up a trial with 4 treatments. One was a full rate nitrogen at 50 units a hectare, which is the green line. The next treatment was a 50-50 split, where we did a 25 units for pre-harvest and 25 units post-harvest. And then we did also a 50%, a post-harvest only, where we applied the whole 50 units post-harvest. And then there's a control of 0N. So this was done over a number of seasons, and here's the data. So week 0 is about 4 weeks after full bloom. So we started probably mid-November here, probably mid-November, I think. And we've gone all the way from used fortnightly total N of the leaf lamina to get to week 23 when just the leaves are about to fall off the tree. And you can really see, with our high end, that that pre-harvest high end, the trees really responded to that. We're sort of up to about 2.5% total N, and you can see that that post-harvest rate was actually a fair bit less. But what is really interesting about this data is it really highlights the strength of the sink of the fruit. So at week 19, the fruit were taken off the tree, and you can really see that spike in all the treatments at week 20 after harvest. So the fruit came off, and you could really see that reportioning of nitrogen into the leaves and canopy at that point in time. And then I just want to move you over to the next chart on the right, and you can see the clear difference between the pre-harvest and the full rate, the 50% rate, and then the post-harvest. So this is actually the fertilizer nitrogen component of the total N. So we can really see that climbing as we get to sort of the midpoint of the season, and there's a little bit less, it's a significantly less data line for our half rate. And I want to point you to this orange line here, which is the post-harvest only line. You can see a spike here at about week 20. So that's when the nitrogen went on, but you can see very little response to that nitrogen. And so this is, the data that we found, and I'll point you to the next slide, we found a much greater nitrogen use efficiency with the pre-harvest application compared to the post-harvest. And you can really see that reflected in this green line up the top here. So all this nitrogen data is going into the tool, and this is in the backbone and drives how we know an apple tree uses nitrogen. So I want to point you to exactly what an apple tree does with nitrogen. So this is at tree dormancy. We applied these fertigation treatments of 15N, exactly the same way that you would normally apply nitrogen through a drip irrigation system. We excavated the whole tree. We had 4 reps per treatment. We excavated all those trees at dormancy after the first seasons of application. And what I want to point you to is the amount of fertilizer nitrogen that was contained in that tree. So we excavated the whole tree, we split it up into its various organs, and we looked at the 15N component that came from fertilizer. We found for the pre-harvest, so this was applied in spring, that sort of a month after full bloom, weekly applications weekly applications for a total application of 50 units a hectare. We found about 9.7 grams of N of fertilizer was contained throughout that whole tree. And what is really interesting is that 50% of that was allocated to the fruit, and that's the green line here. But the other thing that's really important to notice is that we found fertilizer nitrogen was also put into storage. And this is kind of this is some of the physiological understanding that's really important for how we manage our nitrogen, is that we quite often assume that your post-harvest applications are there really to build storage and build nitrogen into your buds. However, we know and we can demonstrate very clearly that your pre-harvest nitrogen applications will do exactly the same thing. And we actually are recommending this now because we can get away with a much lower rate, and we know that we're going to get all the nitrogen that the fruit needs to develop a good sized fruit. We also know that we can allocate nitrogen to storage organs. But it's also really important to know that under both these treatments, we saw no fruit quality difference in the outcome. So we could assume, okay, well, putting on nitrogen pre-harvest is risky because the fruit may delay ripening. We might have less color. We might have less firmness. But our fruit quality data suggested there was no significant difference between these two different treatments. So then we take you to the post-harvest only, and the same amount went on, but it all went on post-harvest, and we found half of that nitrogen. So less than about 50% less of that fertilizer nitrogen made its way up into the tree. So that means there's a lot of nitrogen being wasted. Obviously, there's no fruit there because the fruit's already been removed, so there's not that big strong sink. And you can see this too. The pink, the trunk, and the roots are your big made storage organs and your old wood, and that's where your nitrogen post-harvest has been allocated. And that looks like a lot, but you've got to remember that this root proportion is 41% of 5 grams of fertilizer. Whereas if I pull you over to the left one, we're talking 14.7% of 9.7. So it's actually quite similar in terms of overall amounts. So that's what's really important for us to input into our model. So we've used all that information to model leaf nitrogen, and then we've developed some nitrogen demand curves for leaf and fruit. And we've also, and then so we can adjust that also for different varieties using a growing degree day for other locations and varieties. And we can also do the same for fruit. So we've allocated, we've done a line, a curve there for how much nitrogen gets contained in the fruit over a season and allocated to that fruit and then removed. And we can adjust that for growing degree days and length of harvest window for your different varieties. Again, we've got a knowledge gap for other varieties. We only have data for Gala and Galaxy, which is pretty much the same thing. I'd really love to get more and more data, fruit end data, from your historical records that we can use to parameterize this model. Okay, so all that is the background, and what does the actual front end screen look like? And this is kind of what it looks like. It's supposed to be really simple. It's supposed to be something that you guys can just have a little bit of a muck around with. It's a strategic tool. It's not a real-time decision support. So what you can do, we use pull-down menus to enter the orchard attributes from variety, age, tree spacing, and row width, and that's up here in the yellow. And then you press to update, and that will then adjust all the calculations down below. Then what's really important is that we get your irrigation infrastructure. Whether you need to tell us whether you've got a microjet system or whether you drip irrigate. You tell us the rate, emitter spacing, duration of events, and then the return period, and that gets calculated either on a millimeter per hectare basis or a megaliter per hectare basis, however you prefer to see that information. Then the scaled outputs are produced, including what the expected yields are, what the planted nitrogen requirements are going to be for that apple tree for that season, and then some key phenological dates, and all that data has come from the OrchardNet database, and then tree crop factors. So I want to point you to this tan colored table below. Some of these tree parameters are estimated. So for example, root depth, and there's always going to be a gap in our knowledge here unless you guys know exactly how deep your roots go. But from our soil parameterization work, we've sort of gathered this estimate. And then using the information from above, we can, and the background data from OrchardNet, we can get a bit of a picture on what your expected yields are for that soil type, for that crop, for that year, for that age, for that growing system. And then there's an upper quartile as well. And then what's really important is here. I want to point you to this number 22. So this is the amount of nitrogen that your crop is going to be removed when you harvest your crop. So with this scenario, we're going to be losing about 22 units a hectare of nitrogen from your apple tree crop when you harvest. So, this is an important number when it comes to your nitrogen budgeting over a season. We also know that your leaves, your leaves are going to contain about 46 units a hectare. And this is going to make an important contribution to the mineralization. So when these leaves fall off, whilst a lot of that nitrogen has been withdrawn, some actually gets allocated to the soil, gets mineralized, and then can be available for tree uptake again later on. And then there's some really important information here around field capacity. What sort of millimeters of water is required this is so essentially how much water your soil can hold. This is a field capacity of 403 millimeters. The refill point is 335 and the wilting point is 250. And for your irrigators, for you guys, who might really understand this stuff, this would be really valuable information. If you have a consultant who works with you on your irrigation, they'll really understand this information, and they'll be able to use this data to help you set your irrigation strategy. So then what does the actual output look like? So for example, this is the same story, Chichura, Goulburn loam soil type, Fuji, and a 6-year-old apple tree. But for the purpose of this demonstration, we wanted to show a few worksheets of what Sonata would look like. that displays the tree water use and a function of these factors of age and planting density of the orchard. Of course, your climate's already been selected, your soil type's already been selected, and then you press to recalculate, and the software then estimates the tree water use, and that's this chart on the top here from all historical data, and that's litres per day, right? So you can see some of these, some of this data is up, you can see it up to 30 to 40 litres a day. And then the software will also show the water content of the root zone soil. And this is the water content of the root zone soil. Look, this might not mean that much to you unless you've got a really good handle on what these soil water charts look like. But this will mean a lot to your irrigation consultant. And we've done this over a number of seasons, and you can see what different seasonal variation looks like. And if we can input all this seasonal variation, we can sort of grasp what can happen over a series of seasons. We know for this site that we get an average rainfall of 457 millimeters with a variation of about 143. We know that to keep your trees healthy and happy and produce a very solid crop, we need about 412 millimeters of irrigation. And there's going to be about 605 ETO going on there. So I wanted to move you on then to, okay, we've got that data in mind of about 425 millimeters. We need to know then what that might mean from a monthly irrigation scheduling perspective. And this is data that you can always play with. You can change your age of your tree, you can change your variety, you can change your orchard spacing, you can change your tree spacing. You can start having a bit of a look and scenario mapping, particularly if you're about to set up a new orchard, how much water your trees are likely to use as they get older, for whatever scenario you want to set. So in this scenario here, I want to point you to the bottom chart where in the green we've got tree water use. So we know that a Fuji grown at Tatura, 6 years old, is the irrigation required to grow this tree in the red, is about in January is about 88 millimeters, right? And the tree is going to be using somewhere around 12 litres. And so we can track that over the course of a season. You can see that gets less and less as the tree goes into autumn and increases again as it gets into summer. And so essentially that irrigation has to match the amount of water that gets received through rainfall and the amount that gets transpired by the tree and your grass sward. So it's very hard to see if this is making sense because I can't see any of you. The Excel sheet is going to be given or will be on the APAL website. We're probably about a month away from getting that 100% idiot proof and making sure that we've got no major fatal flaws or errors in it. It's got to go through a statistical software package first to make sure we're telling the truth essentially, and we've ground truth all the scenarios. But here's another scenario here, and I just wanted to show you this scenario because we're in Grove, and what growing an apple tree in a different area is going to look like. So we're seeing a lot less water use in the height of summer because it's a cooler climate, and we also have more rainfall. So we've got here in Grove, we've got 754 millimeters. We don't need anywhere near as much water, 124, and the soil moisture profile looks quite different as well. And there's a greater consistency in the actual climatic situation. So I mean that's really helpful for you to be able to scenario map and see what growing orchards in different climates can look like. And again, here we go. You can taking you down to that bottom right chart. The amount of irrigation required to grow your apple trees at Grove is significantly less, and the amount of water that the apple trees use is significantly less. And you can see there's greater difference between the green line and the red line here. That's because the black line up the top is a much greater ETO and also rainfall that gets delivered to Grove. So look, this is kind of the overarching story of Sonata. I know, it's 20 minutes. It's really hard to kind of give you the impression of sort of what it's all about. But hopefully you can see that there's a whole stack of data that's gone into it. We hope that you can see benefit from it. And I think there's going to be value in perhaps us doing another day like this, in Kevin's office with growers who are interested, poring over what the Excel sheet looks like once it's signed, sealed, and delivered, and then get your feedback on what's really important to assess. That's what we really want to know. We want to know what scenarios you would actually like to have, or what scenarios you would actually like to input. And that's going to be when you might have a particular irrigation strategy that you want to apply. You might, for example, want to build crop size at the end of the season, and how do we do that very quickly? Whilst we can't do real-time scenario mapping, we can do this over a season. So we can make those, if we can map a scenario at the start of the season, we can sort of demonstrate to you what that could look like. So the key knowledge gaps are obviously root depth, the impact of soil restrictions. So we don't know necessarily whether your orchard is particularly, whether you've got compaction issues, or we do factor in slope a bit, but there are some issues there that we are always going to be limited by. We really want to know your irrigation set points. We really want to know your feedback on what when you start irrigating, when you finish irrigating, and what your experience has been on your farm to grow your apples that you grow. And then I think what this tool can actually do is create opportunity for metrics. So we really will be able to have a look at your water use efficiency and do a cost benefit analysis on the amount of water that you've got to use to grow your apple tree relative to that net return of, say, per kilo of apples per hectare, or per bin, for example. And so I think there's real opportunity for us to build that into the model, and but more feedback that we can get from you growers and advisors, the better. So look, that's probably it from me. And I would, very much welcome questions, and also please get in touch with me via email. Kevin's got my email address or my mobile, because I'm very keen to chat about this stuff. Thanks very much.
Thanks very much, Nigel. That was great. And we do have a couple of questions coming in, which is even better. So the first question is regarding irrigation requirements. And do the irrigation requirements vary for grafted trees? And does the rootstock or the fruiting variety have a greater influence?
Yeah, that's a really good question. What we haven't got is inputted in there is a rootstock, I guess, input, and that's because we haven't done the data proofing on various rootstocks of various varieties to see exactly, do those trees use slightly different amounts of water. However, we have done enough scenario mapping with sap flow from various regions across the country of different apple trees to know exactly how much an apple tree yielding 70 to 80 tonnes a hectare is going to use relative to an apple tree yielding 30 to 40 tonnes a hectare. So what we find is that tree size, canopy architecture, and crop especially, drives water use more so than probably what we're going to see, we say a rootstock variety difference, for example. So I would say, and for example, grafted trees, most of our trees are grafted, of course, but I think, your main driver is going to be your canopy architecture or canopy size, and also the crop that you've got on your tree. And so actually about that, what we still want to input into the model is the ability for you guys to set your desired tonnes per hectare. So I think it's going to be really important for you to go, okay, well, I want to produce 100 tonne a hectare. And how much water is that 100 tonne a hectare in this scenario going to use? I think that's going to be really important as well.
Have you found any gaps in the Bureau of Meteorology locations for their weather stations? And is it possible for those growers that have their own weather stations to input that kind of data into the model themselves?
look, there absolutely are gaps. There's no doubt that there's gaps. So there's gaps obviously in the distance from orchard that we can source our Bureau of Meteorology data from, and also there's gaps within years. So there are some seasons that are just absolutely missed. And then I think the biggest downfall is the fact that at the moment we can't forecast. So this is where we really want to get to. We would love to get the historical data from, if growers have got historical data from their actual orchard, that's the best piece of data we can possibly get. And you could send us that, Excel sheet after Excel sheet, and we would just lap it up. But where we want to get to in the future is the ability to forecast. So, and this is what we've pitched for the next round of this project, is we want to turn this Excel sheet into a user-friendly web app that can take on, so BOM does actually have a forecasting tool where you can forecast from 2 to 10 days in advance with all the information that we've got from the background of these apple trees to then predict how to do real-time data prediction, irrigation set point predictions. So yeah, we hope that's the next stage.
Okay. To those of you out there listening, Nigel's data has shown that there's some of the concerns about applying nitrogen at different times of the cropping cycle may not affect fruit quality and fruit colour in the way that has previously been thought. I'm just wondering if you think you might be applying your nitrogen differently into the future and adjusting your fertiliser and irrigations programs, I guess. And it'd be interesting to hear your feedback through our Q&A function if this makes you think a little bit differently about what you've been doing. And just one last question, Nigel. If you applied half the post-harvest nitrogen, do you think that the uptake in the tree would drop by half?
That's a good question. So just to pick up on Rose's point before, I think because we know that the apple tree uses nitrogen so much more efficiently in spring, we think we're not going to have a fruit quality implication of pre-harvest nitrogen because we can actually use a lot less nitrogen. So we're actually advocating for a lot less nitrogen application during a pre-harvest campaign, for example. But we're also advocating, say, split application, so very small amounts split over that 1 to 2 month period. Starting from about a month after full bloom, because we do know quite clearly that your apple tree does very well with its own internal resources prior to that time. The next question is, okay, if we put on half our nitrogen post-harvest, half of what we were expecting, does that tree probably take up half of that? Well, I would think that's probably true. I think, when we did our post-harvest, we used 50 units a hectare. If we had used 25 units a hectare, would we have seen 50% less uptake? I think we probably would have. I think that is probably the way that it goes. Obviously, there's going to be a maximum amount that a tree can actually take up. So, it's going to have a plateaued line there somewhere. But, I think, different. We've got quite a short post-harvest window down here in Tassie. So, the fruit's coming off anywhere between the end of March through to the end of May, and often the leaves are coming off at the same time. So, we absolutely don't advocate at all any post-harvest nitrogen application because the nitrogen is just going to sit there and possibly leach over the winter. So, yeah, look, if you still want to put if you still want to be putting post-nitrogen application on, do a smaller rate, or even put this on a portion of your block, or half a block, or one block, and see what sort of results you get from one season to the next. And your trees have got enough nitrogen to buffer any extremes or small amounts that you do or don't put on.
Okay, we might leave it there, Nigel. Thank you very much. I think Kevin is talking on a similar topic when he talks about his trials, so we might get back to nitrogen in a little while.
No worries. Thanks, everyone.
Okay, it's now my pleasure to introduce to you our next speaker, Jonathan Brooks, who will be speaking about the future orchard, where we are now and where we are going. Jonathan, for those of you who don't know, has been involved in the New Zealand horticultural industry for more than 30 years and has a strong practical knowledge of pip fruit. He specialises in helping professional growers identify and monitor key performance indicators for the orchard business to find practical, cost-effective solutions to help lift performance and optimize profitability. Jonathan, over to you.
Thank you very much. Yeah, so what I'm doing here is trying to take the last 4 years worth of presentations that we've had and amalgamate them all together into one PowerPoint presentation that's down to 20 minutes. So we are going to go through it relatively quickly. So basically what we're trying to do in the introduction is we need to understand that the success of future orchards will be based on ensuring that all the topics are done well. So it doesn't really matter whether it is just climate, quality, trees, labour, technology, all of those things are highly important. And if you have any weak links, then effectively you're going to see that that will be the biggest limiting factor in the production of that orchard. So the first one we're going to cover off is looking at quality. If you're not actively trying to target what the consumer's wanting, you're going to be left behind. It doesn't mean the same thing to every customer, and if you don't understand your target customers, you can't target their quality needs. So when we're talking about our consumers, growers need to get feedback from the customer, whether that be positive or negative, and they need to be supplying what they're looking for. They need to be listening and learning, and they need to keep improving. So it's about making sure that there's just seamless information transfer, making sure that you are getting that information that sometimes stops with the marketer or the pack house, but just making sure that you're actually at the coalface and knowing what the consumer's looking for. Again, it's about listening and learning and adjusting to suit the market. So then focusing on continuously improving. So when you're talking quality, it does take many forms. So it doesn't really matter whether it's looking at bitter pick from poor pruning, light crop loads or low calcium levels, or basically damaged by pests or frost, or even the demand of quality that comes about from when consumers are looking for higher colour, and you need to be reverting to higher colour sports. All of these things need grower understanding and a management focus. So one of the areas that people have been focusing on is looking at either club varieties or company standards from different groups. Variety clubs and marketing groups can help growers with systems, market access and variety brand management. One thing that's important to note, they do come at a cost, and it needs to be considered that they do actually add value to a grower's bottom line. So just in summary, it's important that we all absolutely acknowledge that to be successful for the future, it's critical that you know your customer. The decisions that you're making in the orchard must be considering the impacts that the customer, on the customer and their wants. So knowledge of the customer and the market quality is absolutely key. So next subtopic was about managing climate. We need to make sure we've got long-term sustainable plans around the orchard location and the risks, and whether that be winter chill or frost or hail, heat, drought, fires, all those things. We need to be able to try and understand what we can do and what the risks of those things are. We need to be farming how and where it's suitable to do so, with the right crops, varieties, and the right systems. And when we're making decisions, we need to make sure that they're targeting production and quality alongside the best fit with the natural environment. So just summarising the climate part of it, we need to understand what the risk or reward is from climate on the orchard business, and each specific orchard, the situation of that needs to be understood correctly. And things like the meteorological data and those sort of things, we need to understand using measurements and try and model what's likely to happen now and potentially what's happening in the future, and come up with some plans. whether they be short and long term, to try and minimise the negative effects. Remembering that not all effects are actually going to be negative. There's times and places where that you might be going into some changing climate, and it could be positive for you. So developing climate management systems that fit your orchard business and your blocks. The next bit I'm going to cover off is talking about variety choices in orchard systems. The focus on varieties and growing systems, there's lots of opinions about what's right and wrong. Over time, it's plagued by trends and newfangled fashions. So as much as there's the right things to do, there's always wrong things to do, or things that aren't going to be successful. So one of the things that really is key is the blocks need to change at the right speed. So we do need to change, but we do make sure that they're changing at the right speed. We need to understand the risk and reward of change. So it's not always possible. Positive. We all know that changing things costs money. So does that risk outweigh the reward? And then we need to be seizing opportunities and minimising mistakes. Remembering that doing nothing is not an option for the future. So we have to do something, but we just need to do it correctly. So when we're talking about new varieties, this is the matrix that we put together and showed a couple of years back. When we're looking at a new variety, we need to make sure it's an informed decision. Might be beneficial for tools such as this matrix to help make the right call. Understanding the market fit is a key part of it. The variety, quality attributes, market potential, accessibility, all those things. And then also understanding the financial fit, what the returns are likely to be, the variety risk, how long the variety is likely to be around, or whether it's which part of the cycle it's in, and the production potential of the variety. The next thing that's important, as we covered off before, is the orchard fit, location fit. Does this variety grow well in the climate and orchard location that you're talking about? Does it fit with your harvest timing? You need to understand, does it suit my markets, harvest timing, financial fit, my risk profile, that's another key part of it, location, and another key part is the group that you're actually going to be working with, do they fit in with your own business and your own ethos of people you like working with? So that's a key part in making a big decision on when to look at new varieties. So canopy design, this is just as important. It's about function and personal preference. All of these things here are reasons to think about canopy design. There would be that fruit quality, yield, as places like Batlow where you do have to think about things like snow risk. Other places, it's not a concern for them. So all of these things you need to understand when you're actually coming up with canopy design. As I said before, personal preference, there can be more than one. And one of the things that is really, really critical to remember is if you don't believe in a system, it's guaranteed to fail. So I've seen a lot of areas where people sort of think, oh, I'd be better if it was a different system. Yeah, if that's the way you believe, you're dead right. It's most likely it's not going to work for you. So these are just some of the systems that are out there at the moment, whether it be like a V-type trellis, whether it be a formal 2D type system like we'll see in a video later on, whether it be the FOP system that Plant and Food have been trialling a lot, whether it be just a standard spindle tree. Now, all of those systems do work for growers, and you just got to make sure the guys that are focused believers, they're the ones that make them work. So just when you're talking about modern systems, you need some overarching rules around systems. Whether it be like Craig talks about the SNAP stuff, which is a simple, narrow, accessible, predictable, profitable. And then the next one is where we talk about the light capture, making sure things are efficient and effective, understanding the yield and vigor, variability, making sure that that's well managed, and then all the other limiting factors and management that goes with it. key part is, you need to select the system that has the best fit for the specific sites and overall business. Okay, this is a key area, well, I believe it's a key area that we need to keep focus on. You can't change everything at once. The existing blocks need to perform as good as they can until they're eventually changed over. So the way to do that is make sure that you've got good information on your blocks, and you need to be monitoring the performance in all the blocks. This is one of the key reasons that we developed OrchardNet, was to do this monitoring and do this data analysis and see where the block is actually stacking up. And you need to make sure the block is working to its best potential, and understand where it's at, and make changes where you can make changes. And that might be fixing the block, or that might be removing it. But remembering that upgrading and removing the poor blocks, it can't really be done at a rate of more than 5 to 15% of your orchard in any year. And you want to be doing that year in, year out. So just keep your eyes and ears open. And so the blocks that are staying, you need to see if there is some solutions as to how do you actually make improvements. And just little improvements, they do actually add up. So even though it's not the perfect block, it's potentially, it needs to stay in, and you've just got to work out how do I get some gain out of it. So looking at this here, these trees, this is not the future. This is not where you're going to be in 25 or 30 years' time. But it might be something that you need to farm until you get there, or until you can change it out. So how are you going to do that? Do you go through and put reflective mulch in and get a bit more yield out and grow a little bit more canopy? All of those things need to be considered on the way through before you actually just replace the block. So when we're talking about canopies, varieties and canopies, they need to meet the current and future needs of climate mitigation and management. Quality and customer demands, absolutely critical. They need to get the production and profitability expectations for yourself. And they need to be, we need to also look at task efficiency, labour. How are the canopies designed to make sure to meet our labour needs both now and in the future? It's really important that all the links in the chain are strong. So if you let down seriously in one area, it'll unravel the whole lot. So now we're talking about labour and task management. Labour is a huge cost of growing, and it's a low-hanging fruit for ensuring we're doing it correctly. Sometimes the hardest part is actually quantify what is the right job. So when we're actually looking at it, we need to be thinking about planning, systemisation, monitoring and management. We're looking for short and long-term solutions for maximum results, because sometimes it just runs on the board, and sometimes it's coming in and changing systems and completely overturning canopy design. But we also need to understand the big picture impact. So things like pruning, very important job to be done. If it's not done correctly, what's that impact later on down through the season? So we're talking short-term labour solutions. We're thinking about creating plans. It's got to be data and information-based solutions. We need to be measuring and monitoring whether at the moment when you're out pruning, are you counting branches, are you counting buds, are you looking at TCAs or BCAs? How are you actually going through and making it so that everybody's aware of what they're meant to be doing and they're being checked to make sure it's been done correctly. As I said before, tasks that are done well, such as pruning, they often make it cheaper or easier later in the season. So it's about giving clear instruction. You need to minimise worker decisions. How many branches, how much detail. And then think about the integration of other things, other parts of the management. What other tools do you need to try and achieve what you're trying to get? If you're talking about getting in early blocks or making sure that the flowering's condensed, do you need dormancy breakers? How are you going to manage vigour? How are you going to manage tree colour? All those things need to be put in through. And they're all parts of labour solution. If it makes it easier at harvest, you know, you've got lots of things to do along the way. And remembering lots of small gains do add up. So when we're talking longer term labour solutions, you know, labour efficiency and effectiveness should always be a consideration when you're actually doing big picture stuff. So for labour, it's about the system. It's about changing the genetics and variety, so you've got high colour, so you're not having to multi-pick as many times. It's about incorporating things like robots and sensor technology into your thinking. Is that likely to be one of the things we need to be looking at in the future for helping with our labour problems? Could be Google Glasses, where you're looking at pruning, and so that the glasses themselves teach you what you actually should be cutting off. Or it could be a robot doing all the pruning itself. But it's critical to remember that excellent canopies reduce waste, and waste, you know, is a real problem. So if you're talking about improving labour productivity, you know, we need to just understand what is it that changes the worker's potential. Is it travel distance? Is it tired? Is it how easy you can do the task? Are they motivated? Do they want to be there? All of those things are really, really important. If you want to actually improve their productivity, you need to understand what it is that's likely to make them better or make them worse. So how do we increase the labour output and rate and still achieve the desired quality? It's about changing the worker, and it's about changing the working conditions. So you can do both. So if you're talking about changing the worker, I don't think this guy's going to be, don't think a Kiwi's going to be any better at pruning or picking than this guy. He's able to reach high into the tree. He's got a built-in pouch or picking bucket. Yeah, should be fantastic, except for the fact it's pretty hard to give him clear and simple instructions. It's about efficiency and effectiveness training, minimal movements, reading the trees. You know, how do you actually quantify what needs to be done at pruning or thinning or harvesting? Making sure you've got the correct equipment, and workers know how to use it properly. And workers are also motivated to work hard and do the job correctly. The next thing is making sure that they are being checked and they're given feedback, correct feedback. So if they're doing a good job, they need to know they're doing a good job. If they're not, they need to know that as well. So can't just leave them out there and come back later on and complain because the job's not done right. You need to be keeping an eye on what's going on. The other thing is changing the work. So the work, you know, this is still the norm in New Zealand. People on ladders into picking buckets, but as we've heard before, you know, there's a huge amount of huge rate of height that you're climbing. It's like climbing up Mount Everest once you've gone through a year of harvest. So, you know, these sort of systems where you're actually looking at picking platforms, in some situations, you know, these make a lot of sense. You know, it's about minimal movement. It's about making sure it's a motivational environment. Some people like the exercise on a ladder, but most people find it very, very hard. It's also about ease of task. So how do we actually simplify things? And then when you look at systems, you know, tools such as this platform, what else can you use it for? You can use that for tree training in that block. You can use that for pruning. You can use that for thinning. You can use that for harvest. So what you need to remember is it's about a specific orchard business solution. So you might be in situations where that is the worst decision you can make. There might be in other places where that could be the best decision you can make. So you need to understand what it is for your own specifics. So then we're talking about people. You know, how do we find them? How do we keep them? You know, in the past, grey nomads, you know, have been quite a good source. People we're getting as backpackers. In New Zealand, we're using the RSEs or the island workers, just local people coming through. You know, what is it that motivates them? How do we find them? You know, I've seen some very, very motivated people with a cold morning and a sausage roll or a pie, and it can really just spark people up. So what is it we have to do? And the next question is, what will COVID-19 do? There is going to be less backpackers running around. Less tourists, potentially less seasonal workers. What's that likely to mean for your business? But potentially more unemployed people, so that might be a win. But also the worker hygiene challenges come as well. So it's understanding, what challenges are coming in front of us, and coming up with a bit of a plan on how we can actually improve on these things. So summarising, where are the pickers coming from? How do you ensure they'll do the job you require? And how do you ensure they'll be there in the future? You need to plan and systemize. You need to focus on short and long-term improvement. It's about the right job, it's about the right price, and it's about the right people. So next I'm going to cover off a little bit on technology. So when we're talking about technology, the implementation of the correct technology will be a key piece in the long-term sustainability of an orchard business. At the moment, there's lots of cool toys out there. Not all of them are adding value, and not all of them are adding value in all situations. So, yep, there's definitely some fun stuff coming. Anyone likes the nice shiny stuff, but they're not always giving the return that you expect. So when we're talking about technology, this is the area that we're thinking about. Some big gains being done. The sensing technology, all of those different things being looked at, and finding ways of measuring and monitoring those things in a highly efficient way. Data management, the OrchardNet type stuff, basically being able to grab that information that you've got from the sensing stuff, packet it up into knowledge and wisdom and bits and pieces, and then we can use it properly. So just having the data out of the sensing stuff is nowhere near as valuable as grabbing the data and turning it into something useful. Automation technology, all the things that you see out there, the picking and grading, precision spraying, lots and lots of that sort of stuff being done. A lot of stuff coming over from the cropping type situations, and not all of it fitting just at the moment, but I'm sure in the future it will. And then just the technology of the new orchard designs. There'll be a lot in that area that we need to keep our eyes open for. In summary, not all new technology will provide gains. We need to understand what works and what does not, and it's really important. Need to understand if it's commercially available, if it's cost effective, if it's able to create decisions or actionable outcomes. Needs to be absolutely focused on efficiency and effectiveness, and it needs to be adaptable to the orchard system. So it's something that is going to work with your team. Some of this technology doesn't work well with the teams that are existing. But the key part has got to add value to the business. So if it's not doing that, it becomes a nice shiny. So something that you bring on a little bit of eye candy for somebody. That's one of the risks of technology, is that you can get those things come through. So when we're talking about targeting future excellence, why we need to target excellence, it's about the health and well-being of the community and the environment and the overall sustainability of the orchard business. We need to make sure this is where the future is, this is where we need to go, this is why we have to do it. When we talk about the what, it's about understanding global and local requirements and interactions. It's creation of seamless integrated systems, reduction of waste for the environment and production efficiency, and it's about consumer requirements for taste and nutrition. We need to make sure that that's all being met. And how we're going to do it, it's about individual growers and the entire industry continually learning and understanding what's available, and then integrating the best fit solutions into their businesses. So when we're talking about targeting excellence, the best growers and the future growers will be developing an excellent culture based on quality, based on understanding climate, based on understanding the orchard and the labour needs, and then they're implementing ideas and technologies that focus on just that continuous improvement. So that's where we're going to get our sustainability for our orchards in the future. So that's it, me. Thank you.
Thanks very much, Jonathan. I think you've identified a lot of decision-making points for people. And I guess a lot of the factors that you've summarised, including the system design, the quality, meeting consumer demands and the technology, a lot of those are related. But in your experience in working with the Future Orchards program over the last few years, can you identify where Australia has done really well and made the greatest changes, and maybe also where we should focus in the future? You mentioned at the Orchard Walk in Orange the other day that higher yields are achievable. So what are some of the key points where we can still focus to make changes into the future and achieve those higher yields and pack out quality as well?
I think there's gains in all of those areas. So and I think, and it doesn't matter if it's Australia or New Zealand, you know, you have a greatest limiting factor. So whether that's a slightly weaker understanding of what the consumer is looking for, or whether that's not being able to produce the high production and high quality that you need to be sustainable, or whether it's not understanding the climatic challenges of your region. All of those things, there'll be one of those that'll be the greatest limiting factor. And once you fix that, then there'll be another greatest limiting factor that's you know, so it's a continuum. But in Australia, I see all of the above, and same in New Zealand as well.
Okay, in the interests of time, Jonathan will be back shortly to take us on a tour through the orchards, but we might move on to Kevin now. So Kevin is the FLA for the Batlow region, and I'm sure most of you know him very well. So I will now hand over to you, Kevin, to present the update from the trials that you've been running in Batlow.
So yeah, welcome everybody. Thank you, Rose, for organising today, and I wanted to thank Larissa Vaughan also in the background, who's making sure that things are ticking over well for the webinar. And yeah, welcome to those that are attending the very first virtual Orchard Walk. I wanted to start by saying that DPI has been a proud delivery partner in Future Orchards since it commenced 14 years ago now, in 2006. In the last 2 iterations or so of the project, our role has been as the frontline advisor, or the FLA, as we're commonly known for Batlow and the Orange Bilpin districts, and my colleague Jessica Fernley currently looks after the Orange Bilpin area. From the Future Orchards program, one of the most useful things I've found over the time has been the local trials, which I'll be talking about shortly. The trials or demos, they've been, in my opinion, a very valuable addition to the project, creating an opportunity to put more focus on specific topics of interest for the region. So, and I think there's been a lot of value generated from that. Deciding exactly what we do with the local trials is one of the functions of the Community Orchard Group. And I'd just like to take the opportunity to acknowledge the members of the Batlow Community Orchard Group that met to discuss trial options for this past season. So it's the crew from Seven Springs, Carolyn, Dominic, and their manager Daryl. Batlow Apples with Andrew and Matt McMahon represented. Ralph Wilson from Willgrow Orchards, Jeremy Smart from Tingara, and Jonathan Brooks also from AgFest. And I think I've forgotten to include Ian Robson, who was also at that meeting. So what we discussed as a group as a couple of priorities for Batlow were something on nitrogen nutrition and something on woolly aphid, 2 things which were front of mind for people. And so for our nitrogen demo, I looked at trying to create a visual demonstration of the impact of excess and late nitrogen in 2 Gala varieties. And some of this work, as I'll talk in a minute, was motivated by the work that Nigel and B10 did. And the woolly aphid study, which was basically to do a bit of a literature scan, see what information's out there, what maybe we're missing, and from that develop a field study. So yeah, as indicated for the nitrogen demo, there's B on the screen there with Nigel. Their work was motivational, and some of the key outcomes from their work are listed there. So yeah, and I hope Nigel will correct me later on if I get this wrong. But nitrogen uptake was most efficient with spring fertigations contributing to fruit and storage nitrogen. And summer and post-harvest applications were going mostly to storage, but no more efficient than the spring applications. And it's possible to achieve the same nitrogen status with earlier season nitrogen fertigation and less nitrogen overall. And these presentations will be shared on the APAL website. So there's a couple of links included there, which will take you to relevant papers. So the nitrogen demo was conducted in a couple of Gala blocks, an Alvina Gala block, 6 years old on M26 at that density, and a Galaxy block, 1,000 trees per hectare planted in 2006. So a couple of different situations, different sized trees. And I thank Seven Springs for the opportunity to run that trial on their property. So these were the treatments, basically. Fortnightly applications of nitrogen. In the 2 blocks here, we had 3 treatments, 40 units of nitrogen applied November through to December as fortnightly applications, and a 100-unit treatment which ran from November all the way through to February. And the same in the Alvina, just adjusted rates of calcium nitrate in different water volumes to reflect the different size of the trees. And the treatments were applied. We also had a 0 nitrogen treatment. The grower in this situation didn't apply any additional nitrogen last season, so that was our control. The application method was basically weighing out, diluting in 20-litre containers and then applying with a watering can, because it wasn't practical to try and apply through the fertigation system. So looking at some results in the Alvina, this is just a colour comparison across the treatments. So the first column here is 40-unit treatment, the 100-unit treatment, and then the 0N treatment. And I think myself, I can definitely see much redder fruit in the 0N section. Probably less difference between the 40-unit treatment and the 100-unit treatment at harvest, but possibly also a slight colour difference there as well. And it's important to point out here the difference with what I did compared to what I think Nigel was talking about was our treatments were leading up to harvest, not post-harvest. So I think that's why we may have actually seen an impact on colour there in the Alvina. Here's the same images, I guess, from the Galaxy block, 40 units, 100 units and 0. It was less clear here. We didn't get that definite red difference in the 0N treatment, and I'll speculate, and Nigel might chip in later on, that possibly the larger root systems of these older Galaxy Gala had more buffering against the sort of treatments that we're applying, so therefore less difference. I speculate that might be what caused that. To see if there was any impacts on maturity indices, looked at the 2 varieties here, and the blue columns are firmness across the treatments, orange is sugar or bricks, and the grey is the starch. And all these graphs are saying to me is that there was no real difference in terms of fruit quality or maturity standards at harvest. And I guess that's consistent with Nigel's message too. Just put this one in to show the starch staining to demonstrate visually that there wasn't anything major happening there in terms of starch pattern index, starch degradation. Also collected leaf tissue samples at harvest and sent those away for analysis. I've got a full analysis done. What I've got here on the screen are the total nitrogen and the ammonium nitrogen results. The green bars are for the Galaxy and the orange bars are for the Alvina, and the treatment so we've got 100, 40 and 0. There was nothing consistent that I could pick out of the total N results. But in the ammonium nitrogen results, to me, it seemed that both of the 0N treated sections or panels consistently came out with the lowest readings for ammonium nitrogen. And that could be a reflection of the fact that there was less uptake of nitrate and conversion to ammonium in those areas which didn't have nitrogen treatment. So conclusions for the nitrogen nutrition demo. The original aim was to create a visual demonstration of the impact of excess and late nitrogen in 2 gala varieties. I think we certainly got a visual difference of fruit colour in the Alvina, and it was mainly in the area that had no nitrogen, which turned out a lot redder. The ammonium, as we've just mentioned, the ammonium status of the leaves in both varieties at harvest was lowest in the 0 treatment, and it was unclear. There was no clear difference for the total N, and there were no great differences in maturity of the fruit at harvest. As a follow-up to this trial, I intend to visit the plots at flowering next season, and just see if there's any differences in flower quality across the different treatments. So that's the nitrogen nutrition one, and moving on to the second study, the woolly apple aphid. So obviously, woolly was identified by the community orchard group as an ongoing issue in some blocks at Batlow. So we thought we'd target this one, and the plan there was to undertake a bit of a scan of the literature, not a full literature review, but a bit of a scan of what was out there. And pretty quickly after I started looking at the literature, the first thing that popped out to me that was something that maybe we weren't thinking a lot about at Batlow was the potential role of earwigs as a biological control. And a study done, a thesis study by Stephen Quarrell down at UTAS, looked at earwig genetics, a whole range of factors in relation to earwigs, and also did a study of numbers in apple orchards and how that related to woolly apple aphid incidence and parasitism as well. And so these graphs, they're an excerpt from Stephen's report, and the blue peaks on these graphs are basically the tracking of the earwig numbers in those different blocks. And he looked at organic, IPM, and conventional orchards, and it was pretty clear from Stephen's work that good earwig numbers early in the season can result in very good control of woolly apple aphid. And so the questions for me for Batlow were, what are earwig numbers like in Batlow orchards? We don't know, we don't monitor for them. How do they vary from one orchard to another? And are there enough in Batlow to manage the woolly aphid problem? So the field study looked at 4 sites, and they're listed there, different varieties, very different locations and elevations at Batlow, trying to capture some of that range of location. And we have 1 organic, 2 conventional, and 1 IPM block. At each of the sites, there were 5 earwig traps deployed at each site. They were checked and replaced fortnightly from the 1st of October to the 23rd of December. At that point, we had a bit of an interruption by a fire that came through that everybody would know about. And so there was a period where the traps weren't monitored, but they did recommenced on the 5th of March for a couple of inspections to see what was around late in the season. So this is the main trap that I used for the earwig monitoring. It's basically just made up from rolled corrugated cardboard, and the cardboard that I use is a single-sided laminated flute, which I got from Bunnings. It's a packing material. Unlike ordinary box cardboard, which is laminated on both sides, if you roll it up, the holes tend to be a little bit too small for the earwigs. So if you're looking at trying this in your own orchard, try and get some of the single-sided stuff. The picture on the right is the organic orchard that I'll talk about throughout this presentation. So this graph, that big grey bar, is the period of no monitoring due to the fire. Other than that, the lines are the earwig numbers, average earwig trap per catch per trap over that monitoring period. The blue is the organic block, the red line is the IPM block, the green is one of our conventional blocks, and the purple line, which you may not be able to make out, is running along the bottom of the graph the whole time, and that was the second of the conventional blocks. So if you can think back to that first slide of the woolly apple aphid with those graphs with the blue lines for the earwigs with the peaks, really of the blocks I monitored this season, it was only the organic block that seemed to have those sorts of numbers present. One of the thresholds that I'd seen quoted in the literature was something like greater than 15 earwigs per trap per inspection to get biological control of woolly apple aphid. And at 35 peak here in the organic, we were certainly getting those numbers much lower in the conventional and IPM. Just a photo to show you the difference between emptying a trap at an organic block versus the conventional block. And you've got all these little fellas working for you in the orchard, and this poor guy's trying to do it all on his own. As a little side study to this, I looked at a couple of different trap dimensions because actually in the work by Stephen Quarrell, there was this was, I believe, the size trap that Stephen worked with. It was a 9 by 9 centimetre flat rolled into a tube. And the other one was, which I ended up favouring, was the Washington State trap, which was based on a flat of 33 by 9 centimetres rolled up. And I just wanted to see how efficient they were compared to each other. And they both tracked a peak, but obviously the WSU trap was much more efficient at catching bigger numbers, probably something to do with the larger trapping surface area. I also did one assessment of woolly apple aphid at harvest time to try and capture some information about what the woolly aphid status was in these blocks. And the data on I used an assessment method which is available to growers through the IPM Apple and Pear IPDM website that's currently up through the Extension Oz platform, and there's a link to that later in the presentation. Basically, it was a 0 to 4 rating system, with 0 being nil colonies and 4 being severe. And so the blue columns are the actual assessment results for the different blocks, and there was absolutely nothing in the organic block. There was a little bit of activity in the IPM block, same in the first conventional block, a bit of woolly activity. And if you remember that, the conventional block with the purple line running along the bottom of the graph for the earwig numbers, where we caught none, this is what was happening there. We had quite a lot of woolly apple aphid activity, but along with that we had some parasitism from Aphelinus malo, which is the orange bar. So we've got pretty good activity with Aphelinus around Batlow, but people know it's quite often not good enough to control the woolly. It comes in late, and I think definitely the early earwig populations could be a big bonus to us at Batlow in terms of getting on top of our woolly problems, if we can protect them. And I've put this up, and please don't try and read the text because it's too small. These are just here to prompt me to say that there are articles available that list some of the sprays that we use that are toxic to earwigs that we can maybe look at and review our approach, try and find something that's less disruptive, and try and help build those earwig numbers in some of the blocks that are struggling with woolly. And so the references are there for those, and you'll be able to pick those up later on. So in conclusion, for the woolly apple aphid study, the aim was a literature scan and then a field study. We did both of those. The literature scan identified the opportunity for earwigs. We demonstrated earwig numbers can vary dramatically across the region of Batlow. Earwigs in traps relate to reduced incidence of woolly apple aphid infestation. And the majority of conventional and IPM orchards at Batlow probably have too few earwigs to get biological control of woolly apple aphid at this stage. As a follow-up, I'll be intending to encourage growers to monitor for earwigs and review their chemical usage. As always, when you run observational trials, there's some other things that you see which are worth sort of commenting on. And in the woolly apple aphid study, other things turned up in our little cardboard scrolls. The first one I noticed was, I think, around the 19th of March. Codling moth was starting to come down the tree to pupate for the winter, and they love the cardboard rolls. And that just reminded me that cardboard wrapped around the trunks of the trees at certain times of the year can be a good tool for collecting and removing codling moth larvae, especially if you know you've got a hotspot or something like that. And also then later on the 7th of April, I noticed some woolly apple aphid starting to move down the trunk as well. And I'd never actually put a date on when that happened. So it was interesting to have that learning so that we just know a little bit more about what the pest is doing. And they're basically moving down the trunk to get onto the roots for the winter. Talking about woolly apple aphid moving down trunks, it reminded me of some photos that Ken Kerrison from Pialago in the ACT sent me a while ago. And he put some sticky goop, this product called Tanglefoot, on the trunks of his trees, and he was trying to prevent harlequin bug from climbing up into the canopy and getting on the fruit. To his surprise, it actually worked in reverse, in that it caused a traffic jam of woolly apple aphid heading down the trunk in the autumn. And so with that in mind, I thought, well, why not do that as a little add-on to this study as well? So some of the trees at the block that had the high infestation of woolly apple aphid, I've deployed some Tanglefoot as well, and I'll record what happens there and let people know later on. There's some references which will be on the presentation and available on the website. And other than that, thank you for the opportunity to present the results.
Thanks very much, Kevin. If anyone has any questions, please type them into the Q&A little box at the bottom. That's a great presentation. I think that some of the best research results in more questions, Kevin, and I think you've got a lot more questions to answer now. In the interest of time, we might, and avoiding death by Zoom, we might just move on to the orchard walks in New Zealand. If anybody has any questions for Kevin, please contact him directly at the New South Wales DPI office in Tumut, I believe you're located. So it's now my pleasure to take you all to New Zealand, where Jonathan will take us through some of the leading orchards in New Zealand. Over to you, Jonathan.
The next block that we're going to actually have a look at is a block where Ross is going through the Waimar orchard. Mark came over and had a bit of a visit round a couple of years ago to Mark Erickson. So now you'll get to see his orchard, and I'm sure get to enjoy what he's put together. So thanks.
Okay, welcome everybody. We're here at Waimar Orchard with Mark Erickson, the owner of Waimar, on my right, and Warren Grant, who's the orchard manager, on my left. Welcome Warren, Mark. And we're here in a beautiful sunny Hawke's Bay day today to go through with Mark and Warren one of the blocks of jazz that's on their property, because as you'll hear later, it's a real standout. But first of all, before we get into that, Mark, can you just give us an introduction of Waimar and how the property's evolved to where it is? Thanks, Ross.
As everyone on the Northern Loop knows, I like to correct Ross every so often, so I'm going to correct him and say I'm a part owner of Waimar Fruit Company, Waimar Orchards, in conjunction with my mother and father. So yeah, my wife and I run it with my mother and father, and fourth generation on this property, so caretakers of the land. Waimar in Māori means clear white water. So we're very fortunate. We've got beautiful soils here, and Ross and I have been in partnership together for the nurturing of these crops for probably the last 15 years. So yeah, Warren, our assistant manager, he's been with us for 2 years, and he's got an abundance of knowledge with tree husbandry and a lot of technical aspects too.
This has been a stunning block in terms of its productivity and profitability now for 3 years in a row. And just to give you some idea, the jazz average in this region averages about 65 tonnes per hectare. Normally it packs out pretty well, about 80% class 1. This particular block that's behind us has been doing somewhere between 100 tonne, and this year it did 115 tonne gross per hectare. It packed out at around 85% class 1. The colour was good and the fruit size was good. So although the yield was very high, like way higher than the average, nearly double the average, the fruit quality was superb. So we just want to discuss what they think has actually contributed to this block being such a high performer. So, Mark, what do you reckon it's down to?
Well, we talk about the 3 C's, so calm, consistent and canopy.
Yeah, I reckon we should go in and have a look at the trees, Mark, and have a look at what, you know, what's part of them. So let's do that. Another thing I'd like Mark and Warren to talk about is how they get down to their crop load target, because I think this is one of the fundamentals, is Waimar gets down to their optimum crop load target more quickly than a lot of other growers do, and I reckon that's putting a lot of the resources that the leaf, that the tree produces into the fruit that they want to harvest earlier on. I think that's quite significant, but you know, you want to explain how you do that, Mark. First with the chemical thinning, and then how Warren manages to get that fruit number at hand thinning. So yeah.
So yeah, Ross and I, we have these different recipes from the year before or the year before that. We just keep refining things. It's a living document effectively, and what's working for us doesn't necessarily mean it's going to work the year after, but hand in hand it's been working well for us. The girdle's actually been a real big positive and a big part of that success, because it's given us a reliable flower number and strong flowers going into the chemical thinning. So Ross and I, we come up with those recipes, we try to get the crop load down very early, so the primary sprays are very important to us. And Ross and I will come up with a figure. Sometimes I might put a little bit of extra in there as a bonus, what I call the feel-good factor. But I am quite an aggressive chemical thinner, because for my way of thinking, if you can get the crop load down as quick as you can without overdoing it, because it's all about making sure we've got our canopy full with fruit, then obviously it's going to pay us big dividends down the track.
Okay, another little advertorial here for Orchard Net. So Waimar are very good users of Orchard Net. And every year, every block has a target of what they're going to farm to. And this particular block, we set a target last winter actually, that we wanted to farm to about 110 tonnes per hectare of a 162 gram piece. And as you look at this tree, and perhaps Jack can sort of show you the tree, to achieve that sort of number, we needed to harvest, we thought, about 425 fruit a tree. Now, you don't always get what you thin to in a bin. There's always this pick out that we call it. But last year, Warren, as the orchard manager, had a target to thin these to, and the target was 483 fruit per tree at thinning. So you got it right, Warren. You want to just tell us what you did to actually achieve that?
Yeah, just following on from that, Ross here. Ross does very good work setting up these plans with Orchard Net for what we want to thin to. We'll do pre-counts after we put a chemical thinner through before we hand thin, and we'll get a feel for what we need to thin to on the tree. Whether what we aim for is ideally everything in singles, but that's not always possible. Having done the pre-counts, we garner some good information throughout the block. We set up a recipe of how we're going to hand thin and what number we're going to hand thin to. We'll set up very simple rules for the thinners when they come in for their hand thin, and we'll stick to those rules and monitor that very closely.
Okay, so everyone loves a pruning demonstration, so now we're going to do a pruning demonstration on these trees, take you through what we're doing. Just to give you the fundamentals, we're actually targeting 115 tonne this coming year. We reckon on this block we need about 2.5 buds per fruit. That's where we've been the last few years, and we're happy with the vigor cropping balance that produces. So that means we're targeting about 1150 buds per tree. And we've got to leave the best 1150 buds on the tree. We've got to prune the tree so there's good light to all parts. Typically this is a 3.7 metre row spacing. We've decided that the tree cropping height wants to be no more than 4.1 metres, which Warren's got a measurement on his hydroladder. So 4.1 metres maximum height. We're aiming for 24 branches in the tree, and now Warren's going to take us through how he achieves those goals.
Yeah, we can't stress enough the importance of good consistent pruning. So I'm just about to remove a dominating branch here in the upper part of the tree. We take our big cuts out of the tree first. I'll normally go through with a chainsaw actually, throughout all the blocks, and make those decision cuts. So then when we send the pruners through on ladders, they are not having to think too hard. We'll set them some very simple basic rules. There's another removal of a branch here. That's my 2 cuts up here, and now I'm ready to prune the top of this tree. We always seal our cuts with a bit of what we call garrison. There's also a product called back seal, just to protect the tree against any disease. Starting at the top here, we'll leave what we call one sap drawer on the centre of the tree, and I'll remove any long upright growth first, or anything very close in to the trunk. And then I'll just follow my branch along and look for big spur clusters or wide arms which aren't required. And then I'll just move my way down the tree, follow each branch and be systematic in how you prune. Then things are not overlooked and missed. The rules that we apply for our what we call our detail pruning, we take any upright branches that are right along the plane of the branch. Anything that's laying along the top of the branch that's long and rank we'll take. We'll try and leave side arms where we've got nice open space and light. And then on the ends we sometimes will single the end off. When we've got competition here, we want to reduce the bud numbers. The only other rule we have in here when we have far too many bud numbers and bud density is we will halve up some of these bud clumps, or sometimes total removal. In this situation here, I'm just going to remove this particular clump here and halve it, instantly reducing the numbers. I might even do the same here and just halve that, just to reduce the numbers at thinning time. Yep. Here we go now. So I make my decisions on the fly as I go, and I'll follow each branch. And over the top here has to go a young branch like this. We want it to grow more, so I'm going to run it very slender. Once I've done my main cuts off here, I'm just going to double check if there's anything I've missed. So I might do a few spurs in there, a couple of there. Maybe I'll get rid of that one, I don't like that one now, and just leave that spur. That's a finished product.
Thanks, Jonathan. It always amazes me when I watch people doing these pruning demonstrations and look at the tree structure, how it's possible to train transient workers to do such a really a fine job at creating such a very precise looking tree, I guess.
Yeah, I think that the key part of it is one of the big skills that is absolutely critical, is making sure that you can make those rules simple and easy to follow. If you can't make them simple and easy to follow, then you run out of highly skilled pruners very, very quickly.
Yeah. If anybody's got any questions, please type them in now. I've got a couple questions while we're waiting for everyone else to put theirs in. What's the normal pruning time in these systems that we've just seen?
So when we're talking about the 2D system, a lot of that basis of what we're doing in through the year is around creating the correct vigor status. So Sometimes we will be pruning through the summer, sometimes we'll be pruning through the winter. It's all about what we're actually trying to achieve. So there is no hard and fast rule on when it has to be done. We're using that pruning timing as a manipulation for vigour and potentially crop load as well. And then for the stuff for marks, a lot of the stuff is done as a winter pruning job, but the same sort of thing will happen if they feel necessary to prune in spring. That's fine. A lot of people are doing big cuts in post-harvest too. So while there's still a lot of leaf, just devigorate trees. So.
And just one last question, and then we might wrap up unless anyone out there's got any other questions they'd like to ask. So regarding Warren's orchard, what's the chemical thinning program that he uses? Does he use primary chemical thinners as well as secondary thinners?
That's the stuff for marks. Yeah. So basically he's using primary thinners. He's quite an aggressive thinner, so he's using a mix of ethyl or ethicon and ATS, and sometimes he's mixing the two together, and then he's coming up with secondaries of BAs and NAA as well. So for jazz, that's quite an aggressive approach.
Okay, we might leave it there unless anyone else has got any other questions. So thank you very much. If anyone's got would like to see the videos again, they're up on the APAL website. And if anyone's got any questions they'd like to follow up with Jonathan, please get in touch with Jonathan at AgFirst or Kevin at DPI. And Nigel's offline, he had to go to another meeting. But also get in touch with Nigel if you're interested in the Sonata tool or have any data that you may be able to help him out with and make his tool even better than it already is. Okay, so I'd just like to thank Jonathan, Nigel and Kevin for sharing your research outcomes and insights. And thank you very much to Larissa Vaughan, who you haven't seen, but she's manning the buttons behind the scenes to make sure that this is operating very smoothly. You can find copies of today's presentations and videos in the Future Orchards Library on the APAL website, and a recording of the session from today will be available in a few days if you'd like to revisit any of the information. You can also have a look at the other orchard walks from different regions if you're interested to see what's happening in those regions. Thank you very much for participating. We'd also like to acknowledge that it's co-funded by Port Innovation using the Apple and Pear Industry R&D Levy and contributions from the Australian Government. APAL has more webinars coming up over the next few months as we hopefully slowly ease out of travel restrictions. You can see a summary of the webinars coming up on this slide, and you can find more information on the APAL website under the events tab. If you've got anything else that you're particularly interested in, please let us know. We'd be very keen to hear your feedback. In the meantime, stay healthy, and we look forward to seeing you in one of the upcoming webinars or hopefully in person at the next Future Orchards Walks planned for September. Thank you very much.